Welcome to Homework Lib.
One way to solve these inequalities is graphically. So if we're starting with the first one, 3x squared minus 2x plus 1, we want to know when is this less than or equal to 0. Notice that this is never less than or equal to 0. It sits completely above. So this is a no solution situation. The second case, x squared minus 4x plus 4 greater than 0. Well, it is greater than 0 everywhere except when it is 0, because this is not or equal to. So it's everything except for 2, meaning it's from negative infinity to 2, not included, union 2 not included to infinity. Next one, we want to know when is x minus 1 over 2x plus 1 greater than 3. But if we subtract 3 to both sides, we're thinking greater than 0, and it's a little easier to read. Is greater than 0 from negative 0.8 to the vertical asymptote, which would be when the denominator is 0, which would be at negative 1/2. So it would be from between negative 0.8 and negative 0.5. Using Descartes' rule of signs, you know when the number of possible positive zeros by how many times the sign changes from term to term. So this starts as a positive term, and then it changes to negative, changes to positive, changes to negative. That's 1, 2, 3 changes. So it's 3, or we can think of pairs of possible imaginary pairs. Those come in pairs, conjugate pairs. And so it could be 3 or 1 positive zeros. For negative, we have to find f of negative x and then analyze those signs. So that'd be 2 times negative x cubed minus 2 times negative x squared plus 3 times negative x minus 4. Negative x cubed is still negative, so it'd be negative 2x cubed. A negative x squared is positive, so that's not going to change that sign. And then plus 3 times negative x would be the same as minus 3x. And so we're starting with negative, and we're not changing at all. Every term is negative. So that tells us that it's not possible to have a negative 0 with this function.